Good evening. I was asked to start off the festivities with sort of general advising information. Is that right?
That's correct.
Okay. I think the single most important thing I can show you is the ECE undergraduate advising webpage, right? Which you can get from the ECE. No, that's not what I wanted. Homepage. Slow here. And then from there, undergraduate, not that, undergraduate advising. Okay, that's me. And this is the undergraduate advisor, Amanda Zabana. And there's a lot of useful information here, I think. Most of you are probably familiar with this already, but some are not. There's a lot of information here about what happens if you want to ask for a prerequisite waiver. We don't have very many prerequisite waivers, but there are some that are allowed. There's lots of stuff on the schedule planning and curriculum flowcharts. There's a link directly to the ECE catalog here, which, by the way, shows you the prerequisites and co-requisites for all our courses. Okay. And what else? Most of you are past Circuits 1, so I don't imagine this is relevant. But there's information about transfer credit issues here. And so I would send you to those places for things about like that. Seniors planning to graduate, senior design, et cetera, et cetera. Let's go to the degree plan form. For computer engineering, the degree plan form is fairly straightforward. There we go. It's held up. This is the EE one. Where is the CPE one? Electrical engineering. Ah, right. Sorry. Computer engineering. Oh, it's the same thing. Oh, there's the computer engineering. Oh, why do we have this there? We don't need that. Okay. So the computer engineering degree plan is pretty straightforward. You need to choose 2 of these 3 courses, and you need to choose an ECE elective and lab. Okay. And those things go in here. This needs to be signed by the concentration area advisor, which is Dr. Yu-Hua Chen. There is sometimes difficulty picking an ECE elective and lab because many of the courses that CPE students want don't have labs, okay? And we don't have any 1-credit courses. Well, we don't have many 1-credit courses except for 2100, which doesn't count. So we have added a couple of 1-credit electives connected with Dr. Mayerich's GPU programming course, and also with Dr. Hien Nguyen's machine learning courses. Okay, they now have 1-credit labs connected with them, which are optional. But if you want one of those courses, then that's one place that you can go to get the lab. Okay, let's see. And those are really the only electives for the CPE program. The EE program is a bit more, I wish we could get rid of this, and we can. Okay. The EE program is a bit more complex. We have these 6, we call them concentration areas. Here are the concentration area advisors for each of the concentration areas. So in the end, you need to get your degree plan form signed by the concentration advisor and then submitted to Amanda. And I'll talk about that in a second, but the way you do that is right here. You get your concentration form signed and you upload it here, and then Amanda has it. Okay. Here are the 6 concentration areas, and let's see. I can give brief overview, but you're going to have people in to talk about each of these areas. Okay, so signals, communications, and controls. How many of you had already had signals? Okay, so some of you have taken signals already. I think of this area as sort of the controls area, and by controls, we're usually talking about getting computers to talk to hardware. So we're talking about robotics or general control systems where you need to program a computer to run hardware. There are 2 controls courses in the program, a 4,000 and a 5,000 level course. And that's, I think of this area as pretty much that. Of course, you can't do controls without signals. You're getting signals from your hardware, you're sending signals to your hardware. And so there's a couple of signals courses. One of them is required, 3337. And there's a couple of communications courses, and we put those all in the sort of same group. Electronics, yeah. Oh, okay. Oh. Sorry about that. That's good. Is everybody is that everybody? Okay. Electronics is sort of the classic concentration area. This is what people were doing 50 years ago, before we had a lot of computer topics. I guess applied electromagnetics has always been part of electrical engineering, but this is the classic electrical engineering discipline. Nanosystems. There are 3 courses that talk about nanofabrication, nano devices, nano meaning really, really small. And there is also a solid state devices course. It's called Physical Principles of Solid State Devices. And we talk about how diodes and BJTs and other similar devices actually work. So you get into the semiconductor level courses like that. Applied electromagnetics. So everybody knows what electromagnetics is, right? You probably had 3317 or you're getting there soon. And how do we apply things like solution of Maxwell's equations to engineering problems? There tends to be a focus on, in this department anyway, on microwave circuits taught by Dr. Jackson, and antenna design taught by Dr. Long. But there's other similar kinds of things going on there. Power and renewable energy, fairly straightforward. How do we generate 3-phase power that gets to your homes and your factories? And what's the deal with renewable energy? Renewable energy tends to be DC, whereas what comes out of the wall when you put the plug in is AC, 60 hertz. And so there's a lot of electronics that changes DC to AC and gets it out onto the grid. And so we deal with those sorts of issues. And then computer engineering and computer and embedded systems is Dr. Yuhua Chen. The primary difference is that computer and embedded systems is still electrical engineering. This is computer engineering. And the difference is that the computer engineers take 3 courses in computer science department. Computer science, of course, is in another college. It's natural science and mathematics. And the computer and embedded systems people take 1 with an option for another one. And so the computer embedded systems people have more electives, whereas the computer engineering curriculum is more prescribed. You have fewer electives. Anyway, I won't go into more detail than that unless people have specific questions, since you're going to be doing that during the week, right? Anyway, so the deal here is that you have to take the courses in blue, and then you have to take enough courses here to add to 6 total. In all of these, well, let me back up a little bit. You also need 2 ECE electives, which can be anything that we teach. Well, in the elective area, of course, not the required courses. And you need something called the technical elective. The technical elective can be one of these. Notice there are math courses there, physics courses. I have approved computer science courses for the computer and embedded systems people as a tech elective. If you are interested in a different physics or math course, you can, and you want to count that as your technical elective, you can do that. So there's lots of options here. And if you don't like any of the sort of specialty courses, then you can just choose another 3,000, 4,000, or 5,000 level ECE course to fill that out. Between all of these electives and your tech electives and your concentration electives, so all of them are listed here, you have to have 3 lab courses. Any 4-credit course that we teach includes a lab and counts as a lab course, and any 1-credit course is a lab course, right? So if you look, for example, at electronics, your 3 lab courses are automatic. You're required to take 4119, 3457, 3456. Now you have your 3 lab courses, okay? Signals, communications, and controls has only 2 required labs. So between these electives, concentration electives, and technical elective, you would have to end up with 1 more lab, right? So that's how all of that works. Let's see. Computer science courses are often 4 credits. They do not count as labs, except in this case. We have to do that because otherwise the computer and embedded systems people would have to take 130 hours instead of 129. We discovered that a couple of semesters ago. So in general, computer science 4-credit courses are not lab courses, except for this one, for the computer and embedded systems people only, okay? So that's how that works. I get a lot of questions about the labs, what counts as a lab. So hopefully that clears up some of that. Once you get this filled out by the and then you visit your concentration area advisor, then you submit to Amanda Zabana. Okay. This is all internal to ECE, by the way. eCullen never knows about this. So we can change things as we go along. If you choose different electives, that's fine. But what I would caution you about is the following. There is expected future course offering. So here are all the required courses, and they're taught in fall and spring. But the electives are taught only in fall or spring. Actually, Intro Nano, I got to get with those guys to find out when they want to do this. These electives are generally taught in either fall or spring, and so you've got to be careful that you know when they're being offered, and you have to be aware of the prerequisites. The electives are, of course, not on the flow chart, so you have to go to the course catalog to look to see what the prerequisites are. okay? So let's see. What else do I need to tell you? Questions about that? General questions. Okay. Let me call your attention to something called the Accelerated Master's Program. Application is here. If you're pretty sure you want to go to graduate school, okay, well, here, right? What you can do is apply to the Accelerated Master's Program. The Accelerated Master's Program allows you to take 2 6,000 level courses. Those are first year graduate courses, and apply them both to your undergraduate and your graduate degree. Of course, that's only going to work if you're going here to graduate school. So you choose 2 6,000 level courses. You petition to have them count as your ECE electives, and then you get to use those also in the graduate program, which means you have 2 fewer courses to take to get your graduate degree. Right? The dean's office runs this program. They have a couple of rules. They really want you to apply to the Accelerated Master's Program before you take the graduate courses, right? Some people will take a graduate course or even 2 first, and then decide that they want to be in the Accelerated Master's Program. That can still work, but the dean's office, sends me nasty emails when you do that. Still, it's okay, you can do that. The other requirement is that you can't take those 2 graduate courses now and then come to graduate school in 3 years. You got to do it the semester after you leave here, so it's expected to be continuous. You can still take graduate level courses, but you can't apply them to the Accelerated Master's Program unless you're planning on doing that right away. So those are sort of the rules there. And all the forms to fill out are here. Let's see. Expected course offerings, let's put that over there. What else? That's the basic deal. Of course, the flowcharts are all here, but you know about this. Please be sure that you are following the flowcharts. Senior design has several prerequisites. Some of these are negotiable, but most are not. There is no way you will do senior design if you have not finished electronics, micro P, and statistics. Some of these others, and of course the electronics lab, some of these others are potentially negotiable, but those are not, okay? So be sure that you have these courses before you get here. Let's see. How many of you are going to be expecting to do senior design soon? Okay. You cannot enroll in 4335. You have to be given permission to do well, you can once you've given permission. But if you try to put 4335 in your, if you try to sign up for it, you will be denied. What happens basically is that Amanda Zabana goes through your request to enter senior design. It's another form, I know. There's a special form to get into senior design where you tell her everything that you're going to do for your last 2 semesters. Then she decides whether you can probably graduate in 2 semesters or not. If you can graduate in 2 semesters without taking an overload of courses, she will allow you in senior design, okay? If you can't graduate in 2 semesters, you cannot do senior design. It has to be in your last 2 semesters, and they have to be continuous. There's no space between 1 and 2, okay? Each semester, we do a mandatory advising session where we explain all of that, give you lots of information about senior design and everything else that Amanda's going to do to make sure that you're ready to graduate. We have not scheduled that yet, but it will happen Not going to happen this week. Probably 2 weeks from now, we'll do that. We'll do a couple of those, right? So there will be some advising sessions that you will need to attend in order to be admitted into senior design. By the way, when you do that, Amanda is going to go through everything that you've done. And if there are things missing, you never got transfer credit for English 2, she's going to let you know. And she's going to show you how you can figure out those things yourself. So if she lets you into senior design, it's because you can graduate in 2 semesters if you follow the plan that you give her. Okay? If you change that, you need to be sure that you're not, violating any of the prerequisite rules or any of those sorts of things. I tell you this because I will frequently get emails from students in their last semester or second last semester to say, can you please review my entire schedule to prove that I can graduate next semester? And the answer is no, I'm not going to do that. Amanda has already done that for you, or you wouldn't be in senior design, okay? If you have changed your electives, you either need to let her know or go back to your concentration area advisor and make sure that you're still on track to graduate. But once she allows you into senior design, based on what you tell her you're going to do, she is telling you you will graduate in 2 semesters if you follow this plan. Okay. So, what else can I tell you? Questions?
I have a more specific question. So based on the different concentrations I can choose from, which one would most likely correlate to if I wanted to pursue my master's or go into RF?
Go into
RF engineering.
Radio frequency engineering?
Yeah.
Then by all means, the applied electromagnetics concentration area.
Okay.
Yeah. Right. As far as graduate school, it makes no difference. Your degree, your diploma is going to say Bachelor of Science in Electrical Engineering, no matter what your concentration area is. Okay. So nobody knows from your diploma what your concentration area is. Your permanent record, I guess, has that information. And of course, the courses that you took show that. So the concentration area is simply a way for you to organize your electives into something coherent. That's really all it is. And by the way, let me see if I can find that degree plan form again. Yeah. This is CPE. Yeah. You get 2 electives. Where is it? You get 2 electives and a technical elective. If you were to choose ECE courses for all 3 of these, you would effectively have almost 2 concentration areas, right? Here's a concentration area with 3 required electives. So if you did electronics and then did these courses as well for your 2 electives and your technical elective, you kind of sort of have 2 concentration areas, right? So your degree is still electrical engineering. It's still a very broad degree. This is just an effort to help you organize your electives into something, that looks like a plan, basically. Computer engineers have a different diploma. Your computer engineering degree says Bachelor of Science in Computer Engineering, so that's different. But no matter which concentration area you're in, it still says BSEE. So for graduate school, it makes no difference. If you're interested in RF, then this is where you want to be.
And Dr. Jackson will be speaking about the applied
electromagnetics
concentration at 5. Yes.
Okay. At 5. I got to talk for half an hour more.
Yes, for people in person and online.
Okay.
So I could get a brief, survey. How many of you guys are in like a freshman type of situation?
Should be too many freshmen here, probably.
All right. Any sophomores? All right, and how many juniors? Okay, all right, sounds about right.
Other quest ions.
It's about classes.
Okay, well,
It's a good idea to take a flight and use the system at the same time.
I'm sorry.
Is that a good idea to take a flight and use signals and systems at the same time?
To take, one more time.
Applied EMWIS.
Right.
And signals and systems.
Well, if the prerequisite structure allows you to do it, then fine.
Okay.
Off the top of my head, you need to be in signals and systems co-requisite, right? Or is it a prerequisite? EE flow chart. 3337, you're required to be in them to do 3317, which is applied E&M, you need to be in 3337 or have passed it. Okay. Yeah, there are very few of these prerequisites that I waive. Some. Right? I've had people taking ENGI 1100 who want to go straight into circuits 1. And the answer is, okay. So, you know, this is your first line of defense. You got to be here to do that, or you have to have completed it. Yeah, prerequisites are at this level are very seldom waived. There are a couple of exceptions, but not many. Other questions?
Can you still take digital logic design and circuit 1 at the same time, or is that?
So there is, let's see, do we still have it? 2100, the flow chart says this is the case, but we're going to actually, we filed paperwork to remove that. It's not going to be official until fall, but we still honor that. So 3441 requires, oh yeah, it requires 2201. So you cannot take them at the same time. So if you go right here, 3441, the 2201 is a prerequisite. This is going away, but that's not. So no, you cannot do micro P without circuits 1. Basically, you can't do much of anything without circuits 1. You can do 3331 if you're doing them simultaneously. Credit for or concurrent enrollment in. We refer to the C4E, CFORI, credit for or registration in.
And then for that one, is there any way to waive the EMAT requirement for 3330?
No.
Okay.
So for ECE senior design, is that exclusive to ECE students, or can you work along with like other engineering fields like mechanical?
You can definitely do interdisciplinary senior design. We do it every semester, usually with mechanical engineers. I would love to see somebody work with chemical engineers or maybe biomedical. That seems like it should be an obvious one, but I don't think we've had a biomedical EE project. You know, we have an industry advisory board. It's a group of 30-ish people from local industries. In fact, we can find it. IAB Industry Advisory Board. And these are people who meet with us twice a year, at least. And so you can see they're from all over. Keysight Technologies, HP, Axon. Mark Labor has retired from the board, but Brian Lee is a former student at Centerpoint Energy. People from Microsoft, Exxon. They will tell you that if you're working for their company, especially if it's a big company, it's probably an interdisciplinary project, right? There are very few jobs where you're doing just EE, maybe some computing type jobs, but all the oil industry jobs, you're going to be working with chem engineers, you're going to be working with mechanical engineers. And they really like to see these interdisciplinary projects. I'll tell you something else they like to see. I will often ask them questions like, Mike Hansen is another ECE graduate. Carrie Galloway, I think, too. Rob Black, CEO of Omron, which is an automation and robotics company. Yeah, I will ask them, what do you want to see in our graduates? They almost never say things like, well, you got to do some C++ programming and you need to know how to do analysis of amplifiers. They don't say that, because they know if you have a degree, you've done that. What they want to know is, do you have the soft skills? Can you write a report that other people can understand? Can you give a presentation to your peers or to your supervisors? And is it coherent and does it make sense? Can you work on a team? Right? That's what they want to know, those so-called soft skills, because you wouldn't have graduated if you didn't know that other stuff. And if they're concerned, they'll look at your grades, but I think mostly they don't. So.
Speaking of the IAB, they in fact made a whole document specifying some of the things their industry partners are looking for in students, I think.
Yeah. Let's see if that's here.
Yeah, useful.
Useful tips and tricks. Yeah, here it is. IAB recommendations on skills and knowledge useful in the workforce. They spent a long time putting this together. These are the things they think you need to know, you know, in the general engineering workforce. And here are some specific suggestions, recommendations to the ECE department. And we've taken many of these recommendations. Some of them are not completely actionable, or it's hard to know how to act on them. But many things we took their recommendations. So this is a useful thing to have. I haven't even looked at these. Leverage your networking skills. Oh yeah, Trey Mabane was he retired from the board, but he was a real networking guy. Networking as in talking with other people. I don't mean networking, right? So yeah, take a look at that. And by the way, these people are very anxious to, if you're interested, to mentor your senior design projects. So if you're doing a project that looks like it might have some relevance in the oil and gas industry, then call Roger Dale Brown and tell him, hey, we'd like to get some tips from you about how to make our senior design project work. Or let's see. Actually, Casey Latham is rotating off. Something that relates to power, you know, call Brian Lee, tell him, hey, can you meet with our team a couple of times this semester and give us some tips about how to work our project. They are happy to do that. They're anxious to do that. They wouldn't be on the board if they weren't interested in you guys and helping you out, right? I mean, they don't get paid for this. This is purely voluntary. In fact, a lot of boards are required to make donations. We don't ask for money from these guys. Sometimes they give us equipment from their company, but they don't get paid to do this. What else? So these are all good resources.
A lot of the people on the IAB will be coming to give talks for their respective concentrations. So I know last semester we had Jeff Busby, who's the VP of Weatherford, I believe. I believe.
I forget.
Yeah.
Did I pass him?
Yeah. And then we had Brian Lee. Who works at Centerpoint, and then a whole bunch of other people. Yeah, it was pretty cool to see people, especially some people who graduated from UH or working in jobs. I'm sure a lot of us are interested in. advice or insights and all of that. So,
James Ortiz just retired from NASA. He worked on the James Webb Telescope. He's got quite a history. He has his PhD in control systems from here. And in the fall, this past fall, he taught the second semester controls course. And he's going to do it again next fall.
state space?
Yeah.
Oh,
Yeah, state space. And what else? Doug Verrett is now helping us teach Senior Design 1. He's giving us a lot of pointers on writing engineering specifications, which is something that you guys need to learn how to do. And we are completely, not completely revamping. We're doing a lot of fine tuning, let's say, to senior design based on Doug's suggestions. He's retired from Texas Instruments. He was a project manager for many years on some very big projects. A chip that they designed is on a Mars rover right now. It's one of the control chips for the little helicopter they have on the Mars rover.
it's on the Ingenuity thing, right?
Sorry,
On the Ingenuity mission?
whatever the latest one is, one that has the helicopter connected to it. I think that's Ingenuity, and so Doug was on that team. He's very helpful. So other questions?
So if I could ask you guys, do you guys have any particular concentration you guys are interested in? I know you probably do. But
I'm looking at electronics, but I'm gunning for that. Like, I found going on the sessions. This that's very so I get to understand what's wrong with those. Awesome. Sounds good.
I honestly just wanted more information about what exactly, or like the difference for CPE and EE, and what they have to do in the process.
Yeah, I mean, electrical engineering and computer engineering are both very broad degrees, right? It's not a vocational school. You're not learning how to repair refrigerators, right? And the reason that, you know, people in industry like to hire engineers is because their training is very broad and you can be taught to do a lot of things. I mean, especially if you work for a big company, the first thing that's going to happen when you get there is they're going to send you to training. You just got out of 4 years of school, but they're probably going to send you to at least 2 weeks of training to figure out specifically what it is they need. So this is a very broad degree, and that's why you guys are marketable. I mean, it's specific electrical engineering as opposed to chemical engineering. Those are very different topics, but it's still a very broad degree. And all of the concentration areas are very broad. I would say probably power and renewable energy is maybe the most specific of them. If you want to work in the power industry, you should take that concentration area, which is not to say that at Centerpoint they won't hire you if your, you know, concentration area was electronics, only that you get some very specific instruction in things like the grid, power distribution, power generation and distribution is a huge topic, and they want people who know something about that.
Yeah, in fact, one of our former alum was working at Burns & McDonald's.
Yeah.
Got his concentration in electronics, and now he's doing power related stuff. So I mean, we can absolutely switch one to another.
Yeah, Carrie Galloway. Yeah, Burns & McDonald has hired a lot of our students.
Yeah, they always show up to our IEEE meetings after we
Yeah.
So.
How often do people change concentrations after they've already chosen?
It happens, but it's rare. I'll have people going from EE to CPE or the other way. I can't think of too many cases where people change concentration areas within EE. I got more people coming to EE from biomed. than people who are changing within the EE concentration areas.
That's good.
Yeah, biomedical engineering is pretty specific, and it's, the bachelor's degree is not usually considered a terminal degree. It's expected that you're going to go to medical school maybe, or you're going to go to graduate school.
Which isn't, would you say electrical engineering is a good degree to break into the biomedical engineering?
Yeah, absolutely. Dave Shattuck, I think, has an EE underdegree and a biomedical graduate degree.
Yeah, he got his graduate biomed doctoral degree from Duke and undergraduate
Duke.
from-
Undergraduate was SUNY Buffalo, I think.
Oh.
Graduate degree in, I think, don't quote me on that, but anyway.
I was just, I asked, is electrical engineering a good degree to break into biomedical engineering?
Yeah, absolutely. I mean, electrical engineering to biomedical master's degree is, well, Dave did it, and it's fairly common.
And then additionally, with an EE degree, you could break into, say, the aerospace field. You don't just have to be an aerospace engineering maybe to break into it. There's a whole ton of fields. Even fields outside of engineering, I know a lot of people are quantitative analysts type of roles, except EEs. So,
I mean, the classic engineering fields are electrical, chemical, civil. Civil, I think, was the first engineering discipline. What did I say? Chemical, electrical, civil, mechanical, of course. Petroleum is relatively new anywhere. Industrial engineering, I guess, has always been around. And what did I leave out? Yeah, biomedical. But those classic four, electrical, mechanical, civil, chemical, employers know what they are. When you introduce new degrees like petroleum engineering, you know, even people who work in the oil and gas industry will ask questions like, well, okay, what is it that you know? Right? We know what electrical and mechanical and chemical is. People who work in oil and gas used to come from chemical engineering because they know about chemical processes, and of course that's relevant for refining plants and stuff like that. Computer engineering used to be a little bit unknown, like, okay, what exactly do you do as a computer engineer? Could be a lot of things, and curricula were different at different schools. So, you know, even our IAB asked us at a meeting once, what exactly is a computer engineer? But that was many years ago, and things have settled out quite a bit now. And lots of people from all kinds of disciplines are hiring computer engineers because they understand how important it is basically to connect hardware with software, which is kind of in a simple way what computer engineers do. And electrical engineers can do that too. And of course, you have the same first 2 years and many similar electives. So they're not wildly different degrees. It's just that you have a little bit more specialization as a computer engineer, and you've got some computer science courses. And there's one math course that computer engineers need to take. That's an accreditation requirement. Math, I think 3336.
Well,
It's
they're renaming it to 2306 because of, well, they want people to take discrete math before they take data structures.
yeah.
So
You have to take something called discrete math.
it's pretty tough class, in my opinion, but you basically only take it to CPU or concept.
Yeah, that's actually an accreditation requirement. By the way, in case you're curious, we're having an accreditation visit in the fall. So there will be a team visiting the whole College of Engineering in the fall. And they will have seen a report that we are in the process of writing that has 9 chapters and several hundred pages. And they will be going through all the engineering programs in great detail to decide whether we should get accredited again. And almost certainly we will. I mean, we had one hiccup one year. I think it was, we had a,
Was it with mechanical?
no, electrical had one hiccup. They weren't crazy about certain things that, it wasn't even that they weren't crazy about certain things we were doing. We didn't report it well. We didn't give them enough information about it, and we were required to submit another report in 6 months. And then we were fine. They come every 6 years unless there's a major problem, which we have never had other than that 6-month hiccup. But yeah, the report we generate is unbelievable. There's a lot of detail. How many of your faculty have offices, and where are the offices located? Are they conducive to allowing students to come and visit your faculty? How many computers do you have? Where are they? And what software do they run? Things like that, on and on and on and on. And then there is the assessment and evaluation. We are required to tell them to what extent you have met 7 outcomes. I can show you that if you're curious. Okay, so here's ABET. Let's see, ABET accredited programs. Let's do it this way. ABET student outcomes. Let's see, do you think this would be easy to get to? Yeah, here it is. Criterion 3, student outcomes. We have to collect work that you do and assess it. Not, I mean, it's already been graded by your instructor. Now we have to look at that, we meaning the ABET committee, and we have to answer to what extent you have satisfied these 7 outcomes: an ability to identify, formulate, and solve complex engineering problems by applying principles of engineering, science, and mathematics. And how do we do that? We look at courses like electronics, where you're solving in the lab and in the classroom, complex engineering problems. Here's one of my favorites: an ability to recognize ethical and professional responsibilities in engineering situations and make informed judgments, which must consider the impact of engineering solutions in global, economic, environmental, and societal contexts. How do we do that? Well, senior design. We look at your final reports in senior design and ask you to comment on things like this in your final report. An ability to acquire and apply new knowledge as needed using appropriate learning strategies. We have to come up with data to show to what extent you satisfy these outcomes. And if you ask ABET, what do you mean new knowledge? Do you mean knowledge that they didn't get in school? And what sort of things might that be? If you ask them any questions about what these outcomes mean, what they will tell you is you have to decide what that means for your program and define it however you think is important.
And don't judge that.
Right? Yeah, they won't give you any hints. And so there'll be one so-called program evaluator for each program. By the way, ECE has 2 programs, electrical engineering and computer engineering. So we have to write 2 of these reports, which are mostly the same. It's largely cut and paste, but not completely. And in the next time they come, we're going to have 3 programs, computer engineering and analytics, out in Katy. You can't accredit a program that hasn't had any graduates yet, and they don't have any graduates. So we're not going to, they're not an issue this time around, but next time they will be. So we have to write 3 of these reports. See how hard it is to be a professor? You guys just don't appreciate us.
Wait, do they, does ABT also have to accredit graduate degrees if they've already accredited?
You can accredit graduate degrees. We have some form of accreditation, but it's not ABET. And to be honest, I'm not sure what they're doing. But yeah, our graduate programs are less often accredited. The entire university is accredited by something called SACS, Southern Association of Colleges and Schools. And we have to report to them too, although it's a lot less onerous. We just give them some data that we got from our ABET evaluation. But all these things are going on behind the scenes. Ooh, there's a question in the chat or a comment in the chat. Are there any computer labs that have multi-sim installed? Multi-sim is available for free online. Do multi-sim live in your Google search bar and it will come up. The free version is good enough for anything that I could imagine you would do in, let's say, circuits or electronics or digital logic. There is a more powerful version that's available for $40, I think, but I don't think it's installed. So the answer to your question is no, but you can get it for free online.
Question. So I understand that we have obviously our master's in electrical engineering, and I believe that the computer engineering program has a master's, but
Yeah.
it's in computer systems engineering.
That's right. It's called computers and systems engineering. So let's see. Got so many tabs open, I don't know where to go anymore. If we go back to the main ECE webpage, graduate degree programs, PhD, Master of Science in Electrical Engineering, both a thesis and a non-thesis option. There are certificates, which I think means you've taken 3 courses. And this is it, Master of Computer and Systems Engineering.
Dr. Hahn is the advisor for that.
Yeah, he's the,
I thought he was in charge of signals.
sorry?
I thought he was in charge of the signals concentration.
No.
Oh, that's Chef.
No, signals concentration is Bob and Chef. Director of Graduate Studies is David Jackson. Doesn't say that anywhere here, but that's the case. So he's my counterpart in the graduate level.